Hi, everyone, and thanks for listening. Today, we're going to be speaking with our own Matt Sooy about industry acronyms. But first, the METUS Minute.
This METUS Minute is talking about terms used when discussing A2L equipment. So here's a glossary summarizing some of the terms we may see in some of the manuals. First is A-min. A-min is the room area in square footage where an indoor unit will be installed. TA-min refers to the room area in square footage where indoor unit will contain supply or return ducts. The M or M-max refers to the maximum refrigerant charge allowed given the A-min. H0 indicates the unit installation height measured from the floor to the bottom of the unit. And MC is the planned system charge. Thanks for tuning in to today's METUS Minute. Now let's start the show.
The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The METUS Tech Show.
Mitsubishi.
All right, Matt, so you were talking about sushi?
Yeah.
Yeah, so what's the go-to sushi place? Because you live in the Worcester area, right?
Used to.
You moved again?
No, I moved 5 years ago.
Yeah, where do you live now?
Holliston.
Oh, well, technically, I guess I would call that Metro West, not so much Worcester.
That's right.
All right, because I thought you lived out further west.
And for the listeners that are wondering, where is Worcester and Holliston? That's in Massachusetts.
Massachusetts, right.
Yeah.
Worcester.
Worcester, as the outsiders say.
Yeah, it's Worcester. All right, so what's the go-to sushi place in the Metro West Boston area?
So Takara in Medfield is our go-to. So it used to be in Worcester, it was Sushi Maezawa. Really small, hole in the wall.
Yeah.
Excellent sushi chef, Mitsubishi cooled, of course.
All right, of course.
But yeah, that was always our go-to. And if we might get back that way, we always go to Sushi Maezawa.
All right, so let's kick it up a notch. Where's your favorite, the best sushi you've had in the country?
In the country? Well, Sushi Maezawa is really good. Actually, Atlanta has some pretty good sushi spots too, surprisingly.
They got a lot, yeah.
Yeah, there's a strong Japanese presence, Korean, Taiwanese maybe. So there's a bunch of restaurants down in the Atlanta, Swanee area that are actually pretty good candidates for sushi.
All right, so what's the name of the place in Medfield?
Takara.
That's probably about, 30 minutes from here?
20
minutes? So if we drove there after we finished this show, what would you get?
There's a couple rolls. So there's like a jalapeno popper. These are all Americanized rolls too, so I'm going to sound terrible in terms of my sushi quality. But there's sushi poppers, which is like tuna over a jalapeno that's fried. There's a Wellesley roll. There's, I think, a Patriots roll too, maybe.
My favorite one, because we got a sushi place next door. I don't go there a lot. I mean, it's not, I wouldn't call it, like Michelin sushi, but it's pretty good.
God, no.
Yeah. But I get the eel and cucumber roll, and then the spicy yellowtail. And they have a spicy yellowtail and a spicy tuna. And I don't know what the difference is, because yellowtail is just tuna. But sushi comes in a couple of different ways. So you have nigiri. Right? Do you get that?
Yeah, the sushi over the rice.
Yeah, that's just like literally raw fish over like a roll of rice or something.
Yeah, more classical.
Yeah, and then you got the sashimi, which is just a piece of raw fish.
Correct.
And I've had that, and it's not my favorite, but it's okay. You put soy sauce on it, and it'll kill, that makes everything taste good. And then the maki is the roll, which is the whatever you're going to put in the middle of the roll. It's rolled up in some rice that's pretty sticky, and it's got some seaweed wrap around it. And, you remember, we went to that place in Westboro, closed down, but it was the Sushi-rito. Remember?
Yeah, the combination of...
it was Mexican-Japanese fusion.
Yeah, the wife was Mexican, the husband was Japanese, and it was combined the two.
Basically a sushi roll, and in the middle was everything you'd find in a burrito.
Right.
It was a Sushi-rito. And I wish they had still around because that was really good.
Yeah, they were good.
You know, you hear I'm very quiet through this whole conversation because I'm really trying to like sushi. My wife loves it. When I go to Market Basket, they have the sushi chefs there. I'm making all the sushi. All I know is like California roll, spicy ahi tuna, and I just get those for her. But Ed Blair had mentioned a sushi restaurant in Georgia where there's a screen at your table, supposedly, and there's a video game that plays, and the more sushi you eat, the more these videos come on, and there are different characters that fight each other, cartoons, and the whole goal of that whole experience at the restaurant is to eat as much sushi as you can to get that character, your character, to beat the other monster and fight him off, and yeah, it's, I guess, a big deal.
Yeah, we have to go there. But you know what? You know what would make you appreciate sushi, and you'd probably like it, is there's a trend going around about these people trying to eat this like fermented herring. It's like a delicacy in Finland.
Oh, God.
And you watch these YouTube videos, and people open it up, and the smell is so overpowering. People start dry heaving and gagging.
Yeah.
So if you tried that and went from that to sushi, be like, hey, sushi's not that bad.
It's probably cooked fermented herring.
It is.
It's the whole cooked thing. Now, if we could take a sushi roll and roll it in some batter and then throw it in the deep fryer, I'd probably eat it.
That's tempura.
Yeah, exactly.
Yeah, and I don't think you'll get that in Japan though.
Not in Japan. In America, you can find that.
Yeah.
Those are for the people who can't stomach it.
Down my alley. But
all right, well, that's enough about that. So, hi everyone, and welcome, and thanks for listening to the METUS Tech Show. My name is Paul Shavs, and in studio today we have Steve. Steve, say hi.
Hey,
Steve Pimentel. And our special guest today is Matt Sooy. So Matt is with METUS. Matt, tell us what you do.
I am the Director of Residential Product Management.
Okay. And what exactly does that mean for those like me who have no idea?
I don't even know myself. But the general gist of it is working with the factories to develop products to bring to market and sell into the Americas through METUS.
Sounds like you're a people person. So.
I deal with the engineers.
You take the drawings from the engineers and bring it to the customer.
It's a very important job.
Yeah. Okay, that's an Office Space reference.
Yes.
So we're going to talk today about acronyms. And there are, I think I found a website and I searched for HVAC acronyms, and there's like hundreds, like 300-400 at least. But we're not going to talk about them all. But our industry, HVAC, is an acronym itself.
Right.
You know, obviously it's heating, ventilation, air conditioning. Sometimes you put the R at the end, it's refrigeration. AC is an acronym. Either it's air conditioning, alternating current. There's a bunch of them. All of our refrigerants, HFC, HCFCs, CFCs, are all acronyms.
It's funny. I was sitting at a bar the other day, and someone next to me said, "Hey, what do you do for a living?" I said, "HVAC," and he said, "What's that?"
What?
No,
Heating, ventilation, and air conditioning. He said, "Oh, okay, HVAC."
Yeah, if you want to sound fancy, you say, "I work in consumer electronics."
Nice.
That's a good one. I get to use that one. Yeah. And then ASHRAE. Yeah. ASHRAE is a very common one. Let's start with that since it's in the A's, and I'm looking at my list, and it comes up. So what is ASHRAE?
Let's see, the American Society of Heating, Refrigeration, Air Conditioning Engineers.
Right. And what do they do that's important for us?
They create standards along with ANSI. So there's things like ASHRAE 34, which is refrigerant classifications, ASHRAE 15, refrigerant application safety standards for how you actually install this stuff.
Yeah, so
a whole bunch of other ones.
Yeah, so we're in the process of going through a refrigerant transition, and they're the ones that set the classifications of our refrigerants, which we're going to A2L. So
yeah, fun times.
Yeah.
Now, you used an acronym to explain ASHRAE. What is ANSI?
American National Standards Institute.
Yeah, I'm one of those that hears that, like a lot of other people and contractors that come to class, and they hear these acronyms. They kind of know what they are, but they don't know what they stand for. Right?
No.
Yeah, and that's why we're doing this show, because I was talking to a contractor, and we'll get into this a little bit later, but we're talking about COP and SEER, and he's like, what is that? What exactly does that mean? So I said, you know what? I bet you there's a lot of people out there, they can tell you COP, that's coefficient of performance, but what exactly does that mean? In SEER, they can tell you what it is, but maybe they can't tell you what it means. So that's what we're going to get to.
And they may know that a higher number is better or a lower number is better, but what is that number? What does it mean, right?
Right.
Yeah. And then, other organizations, NEMA
Oh, yeah.
is one of those that affects our industry, and that's National Electrical Manufacturers Association. And all on our name tags, it has MCA.
Yeah, which is made up terms. Made up circuit ampacity.
Yeah, ampacity. I don't think that's a word. Ampacity,
I don't think so either.
And then you got, what's a
MOCP.
MOCP, maximum overcurrent protection. That's basically the fuse size. And see, there was one here I was looking for, and I wanted to.
What, BTUs?
Oh, yeah. No, here's one for you. CVR MSE. And that's coefficient of variation of the root mean square of the error.
Yeah, we use it every day.
Yeah, obviously that's elementary. There's no need to go into that.
Of course,
I think a third grader knows.
Yeah,
what that
we
is.
learned that in school.
Yeah. There's another one. There's ERV and HRV, energy recovery ventilator and heat recovery ventilator. What's the difference between the two?
Well, energy is more than just heat. Isn't that obvious?
Yeah. But pretend like I don't know.
So energy is made up of heat and in terms of humidity or wet bulb. So if you're an ERV, you're doing both heat and humidity. HRV is just heat.
Yeah. So it's just a heat exchanger. You bring air from the outside, you exchange it with air from the inside. And the heat recovery ventilator is just doing
one of the two.
The sensible heat.
Right.
And it's not doing humidity. That's what I would put in if I owned a gym and I had a shower locker room. That's what I would throw in there.
Right. You don't want to recover that.
You don't want to. You don't want to recover. But if I in my house or in a building, I want to get that energy back. I don't want to waste it. So I'm gonna put an ERV, energy recovery ventilator.
You got it.
All right. And here's another one I didn't know what it stands for. HEPA. Steve, did you know what HEPA stood for?
No, but working in a hospital, HEPA filters are very important. I just never really realized what it stands for, which is high efficiency particulate air and type of air filter.
But then that crosses over to Merv.
Right, Merv. Yes, we all know Merv.
Merv Griffin.
He's a good guy.
Merv isn't even on my list.
Exactly. So there's a million. We just keep pulling them out of the blue.
Okay. Of course, we got RH, relative humidity, and then we got all the refrigerants. We have the CFC, which was your R12, R11, which I used to love R11. You could clean anything with R11 because it wouldn't boil it's like 72, 75 degrees. I miss that. And then you've got HCFCs, which was like R22, which is gone away as well.
You gotta define the word. Say it.
Oh, CFC, I can say it. CFC is chlorofluorocarbon.
There we go.
HCFC is hydrochlorofluorocarbon. HFC is hydrofluorocarbons. And then all our refrigerants come in R, refrigerant with a number. And the number tells you basically,
the classification by ASHRAE 34.
Yeah, it just helps us identify it, whether they're zeotropic, azeotropic, or near azeotropic. And I probably pronounced that wrong. And this transition we're going through is all because of GWP.
Correct. Global
warming potential.
So yeah, we're all moving to HFOs now.
Yeah. Which HFO?
Hydrofluoroorofin? Orphan? That's the hardest one to say.
You don't fill me with confidence when you end that with a question mark.
But going back to MERV filters, and I get this question a lot in class from students when it comes to our ducted units, our Mitsubishi heat pump ducted units, our SEZs, PEADs, and correct me if I'm wrong, but MERV filters, the higher the number, the more that filter is able to collect smaller particulates, right?
Correct.
So is there a limit to the size or type of MERV filter that we can install in our ducted units where, have you heard of anything like that where there's a limit on that MERV filter where it's going to block airflow or cause a pressure loss or anything like that?
Yeah, I mean, there's always a theoretical limit as far as what your ESP can handle. There we go, is another one.
Yeah.
External static pressure.
Yes.
So the higher the MERV rating, the higher the static drop through the filter.
Okay.
So theoretically, you could have a MERV 13 on a ducted unit, not an SEZ, because it only has 0.2 of an inch of static pressure.
Good point.
But the more you take up with that filter, the less you can take up with ducts, registers, and diffusers. Which gets into, say, ACA Manual D.
Yeah, manual D. Oh yeah, and there's also a whole nother manual. I can't remember what it is. I want to say it's manual N, but that's just for registers and boots.
Yeah.
Is it manual N?
It's not a very popular one.
Yeah, it's not
J, S, and D.
Yeah. All right. And while we're talking about that, because I need to consider that when I'm designing a system and putting it together, there's also SHR for sensible heat ratio. And also, if I'm sizing, there's SHFG, which is solar heat gain factor.
Yep. Well, they're fun acronyms.
Yeah. So those, I'm not going to get into those because that's for sizing. And as engineers, there's also OAT, outside air temperature, RAT, return air temperature, all these things that when you're designing, especially on a commercial piece of equipment, you need to take into account the FA, the fresh air, and all kinds of things. So I don't want to go down that road.
Again, dry bulbs, wet bulbs.
Yeah. All right. But let's talk about, and the reason we came up with this, actually, the reason I had this idea for this episode was, like I said, I was talking to a contractor and he was asking me, well, why do I need to know the COP? Why do I need to know the EER and the SEER and all that? So let's just go alphabetically with those. EER.
So EER is a cooling instantaneous load metric. So it's designed to represent full load efficiency at 95 degrees ambient.
Yeah. So EER is energy efficiency ratio, and it measures the cooling efficiency. So if I'm comparing apples to apples and there's an EER rating on a piece of equipment, what number am I looking for?
As far as what your target number should be?
Yes.
So something 12 or above is usually good. I think Energy Star, rest in peace, had it at 11.7 or something in that neighborhood.
So the higher the number, the better.
The higher the number, the better. The name of the game with all of this is the higher the better.
Okay. And then that brings us to SEER, which is SEER, which is seasonal energy efficiency ratio. What am I looking at with SEER?
So SEER is designed, as the name implies, it's efficiency over the course of the cooling season. So, of course, higher number, the better, but this is designed to show your total output divided by your total input. This is correlated using AHRI's equations for how you derive this, but it's showing you what it could do over the whole season as opposed to just EER, which is your instantaneous metric, just at that full load condition.
So both EER and SEER are just cooling only.
Correct.
We're not talking about heating.
Correct.
Because in heating, not for us, but there's AFUE,
right,
which is annual fuel utilization efficiency, and that's a measuring of a gas.
Yep. Furnaces, boilers.
Yeah. So we're not going to go there.
Always less than one.
Always less than one. Exactly, because there's no such thing as 100% fossil fuel.
Right, because you're always going to have losses due to combustion, due to heat loss.
Some heat's going up the chimney, out the flue. They can't do that. So we're not going there. So back to the SEER. So I just took out a 13 SEER unit that was in my house. It was 22, 23 years old. And I put in, I don't even know what the SEER rating is on my piece of equipment that I just put in. I just put in a PUZ with a PVA. I probably should know what the SEER rating is. I don't.
So how much you care.
But let's just take one number. Let's just take, when I was in the industry, when I started in this industry, they just set 10 as the minimum SEER rating for equipment that you could put in. And 10 and 12 SEER were all you had available. That was quite a while ago.
Those are your DOE minimum efficiencies?
Right.
Yeah.
Right. So let's just keep it between 10 and 12. I don't recall hearing anything rated as 11 SEERs, either 10 or 12. So what's the difference in my wallet between a 10 and a 12 SEER?
So these are all, take it with a grain of salt because everything is lab conditions.
Correct.
But they do have the energy guide labels that will tell you approximately what you're saving over the course of a cooling season based upon a defined utility rate, something lower than we pay in Massachusetts here. So maybe it's $50, maybe it's $100, but the guide label will tell you exactly what it is based upon the SEER rating. Okay,
and the higher the SEER, the better I am.
Correct.
So is there a percentage that I can correlate between a 10 SEER and a 12 SEER?
That's for what the dollar savings would be?
Yeah, like what's the efficiency difference between a 10 and a 12? Is a 12 10% more efficient than a 10, 20%, 25? Is there a ratio, a number we can do for that?
There's no like golden rule of thumb. that you can use for it. So it's better, and there's assumptions that are cooked into those energy guide labels. But there's no like, hey, if we bump up to efficiency points, we're going to save $50 a year.
Yeah, and all of these things are done by some organization that's setting a standard. EPA, whether it's ASHRAE or ANSI or whatever, they're setting a standard. And the key word you put there was lab conditions.
Correct.
That's the same way they test our equipment. AHRI. There's another acronym. AHRI. We didn't talk about that one. So let's back up a little bit. And what does AHRI do?
The American Heating and Refrigeration Institute.
Okay.
And different than the AHR show, which everyone seems to call that one.
Yeah. I get
I'm going to AHRI this year.
Yeah.
Right.
Which that one has nothing to do with the other.
Correct.
Okay. So why do we have to care about AHRI?
So to sell equipment and meet minimum efficiency standards, meaning reporting standards, we have to rate it to the applicable AHRI standard. So in the case of residential equipment, like we're talking about today with SEER, that's AHRI 210, 240.
Right. And AHRI just sets that, and they test it, and they require you to test it at a certain temperature. And with our variable VRF, the compressors, the variable speed compressors, the inverters, I couldn't think of the word inverter there for a second, but they require us to lock it in at a certain frequency, which is it's good for testing apples to apples, but it's not going to give us a real number either. It's just going to, because I'm not at my house, my compressor is not going to be locked in at a set frequency.
Right.
It's going to be varying up and down as needed. So, but this is so we can compare apples to apples. And I think the two temperatures, 17 degrees and 47.
Yeah, for heating.
For
and then
heat pumps.
you got 5 degrees now too.
Yeah. Okay. So AHRI sets those, and if you want to sell equipment in the United States, it has to meet those standards.
Right, because AHRI also shares it up to DOE, and DOE is ultimately the one who's got the jurisdiction over what can legally be sold.
And DOE is another acronym for Department of Energy.
Yeah.
Which does the EPA, Environmental Protection Agency, fall into DOE, or are those separate organizations?
Well, today they're separate, but EPA has been drastically undercut with all the budget cuts, hence the whole end of Energy Star as well. So that whole department's gone from EPA, and EPA's kind of been gutted as well.
Really?
I didn't know that.
You guys didn't know Energy Star is gone?
No, I didn't.
Yeah,
I knew
that's my rest in peace gone.
Yeah, I know. I had a feeling. I just assumed that was it. But I know I had a lot of people I worked with at the EPA that I can't get a hold of anymore. So,
yeah.
So I need to buy a new water heater for my house. I'm not going to see that Energy Star sticker on that water heater anymore.
Correct. So the stickering, the reporting, as far as the Energy Star database will all go away. Maybe it'll be absorbed by DOE. Maybe it'll just be carried on by the states. But
okay,
as far as it being part of EPA, it's no longer.
Interesting.
Okay. All right. So we've been bouncing around a little bit. We had EER and we had SEER, and those are just strictly air conditioning.
Right. So if you had a cooling only AC, it would just be SEER and EER.
So for heat pumps, do I have to have a SEER rating and a COP, or just a COP?
For heat pumps, you'll have a COP as well.
As well, but I need both. I can't just have one or the other.
Well, you'll have SEER, EER, HSPF, and then COP.
Okay, HSPF. Okay, well, let's just take them one at a time. Let's go in alphabetical order. COP.
Coefficient of performance.
Right. What does that tell me?
That tells you essentially the same thing as EER or EER, where it's an instantaneous metric in terms of what your output is divided by your input. Arguably, there shouldn't even be such a thing as EER because it's the same thing as COP. It's instantaneous, but it's not dimensionless. So I don't know why we decided to do this, not just have COP across the board, but you have EER for cooling, you have COP for heating.
But COP would tell you both.
COP would tell you both. COP is just dimensionless. So you just take BTUs out divided by BTUs in, and that's your COP.
And the higher the number, the better off you are.
Correct.
Okay.
So it's measuring your efficiency. If your output is greater than your input, you're at a better state than if the two are equal. So theoretically, you should never have a COP less than 1 because that means you're destroying energy.
Which is
okay.
Which is AFUE.
Yeah. Which is
if you
AFUE.
go less than 1, you move over to AFUE.
Yeah. We could get into thermodynamics and the laws of thermodynamics, but I don't want to do that.
There's nothing like describing a psych chart.
Yes.
Verbally.
Yeah.
Really invigorate the listeners.
Let's not go there.
Without having to graph it. Okay, so you mentioned HSPF, and to me, that's like my wife says, make sure your HSPF is 30 or better when you go to the beach.
Yep. Don't forget, you have 70. Reapply every hour.
Is it the same? Am I imagining things, or is it the same acronym?
SPF.
SPF. So it's not SPF.
It's not HSPF.
Okay, so I don't know what that SPF for suntan lotion, but we're not talking about that. So HSPF is heating seasonal performance factor.
Right.
And we use that with heat pumps as well.
Right. It's the heating equivalent of SEER. So it's measuring your total output divided by your total input over the course of a heating season. So designed to show you how much energy you would put out versus how much energy you take in.
And in all of these, the higher the number, the better you are.
Exactly. So that's universal, regardless.
It's universal. So it's the higher the number, the less energy you're spending, or the more money you're saving, if you want to look at it that way.
Right. The most bang for your buck.
Okay. So I've got EER and SEER, which are for air conditioning, and COP and HSPF, which are for heating. And we're either looking at it instantaneously, what am I getting right now, and the system is running under lab conditions, or I'm looking at the whole season.
Right.
And I'm curious now, because the heating season and the cooling season, so we're up in the Boston area right now, but our heating season is, I'm going to say, maybe not dramatically different than like Atlanta, but it's slightly different. Because you go to Atlanta in September, it's still hot. Like,
correct.
You can still hear the sun sizzle. It's so hot. And I'm not going to say we'll turn on the heat in September, but probably by October we're turning on the heat. Maybe in Atlanta they're not. And if I go further south into Miami, I don't think they ever turn on the heat.
Yeah, maybe one day a year.
Yeah.
Or you get that freak storm where it snows.
Right.
Yeah, and everybody panics.
Well, they can get away with electric heat down there.
Without electric heat.
To your point, this is actually a good question. So there's different regions associated with HSPF values. Everything right now is assumed at region 4, but there is also a region 5 that's used by Canada.
Okay.
So then you get different bin hours and different weightings as far as what your HSPF would be. So an HSPF region 5 is less than an HSPF region 4.
Oh, wow.
But for what we're talking about today, everything is in region 4.
All of these things we're talking about today, is this the U.S. only? Is it the U.S. and Canada, or is this a worldwide thing?
U.S., Canada, Mexico, Caribbean, as far as what's covered by AHRI.
Okay. So if I was in Europe right now, because we do have some people listening to us in Europe, I think we're up to 87 countries, but something happened. We're back down to 86. So somebody must have deleted us.
Well, yeah, Greg's trip to Africa and listening.
Yeah, that
over
was
there.
the first one. He was the first one, and then we had Cole, a listener and a contractor who's actually been here. He went to Fiji and he listened there on his vacation with his wife. I'm sure she was happy. Well,
it's a long plane.
Yeah, and Greg Hasselbarth used to work for us. He used to be the director here in the Northeast. He went on his honeymoon and was listening to us. So,
That's right.
Well, what does that say?
So Matt, for our contractors, when they're using Diamond System Builder and they go into...
You mean DSB?
Exactly. Yes, DSB, another acronym. So they're using DSB and they're going in and starting a project. They're going to select their location manually. Where do those, not manually, but automatically, where do those numbers come from, the wet bulb, dry bulb for that region?
So they're loosely based on ASHRAE weather data. So you can get the whole... I think 2021 is the latest copy, but you can get your total ASHRAE weather conditions for every location, every airfield across the U.S. And that'll give you your ASHRAE like 99 versus 996 heating design condition. It'll give you your cooling condition and also give all your extremes if you want to size to those.
Yeah.
My other question is, are those changing quite often, or is that stay pretty standard?
Yeah, I mean, your sample size is over 100 years or something like that. So everything stays pretty stable regardless of these freak heat waves or polar vortexes that come through and kind of skew things. So they're buffered out by the size of the data set.
You know,
Nice.
But you just reminded me of something. I think it's important. It may not be exactly the acronym, but it's ASHRAE, so I'm going to go with this. But I remember when I first started with Mitsubishi, there was a complaint. Somebody was calling in, and it was a heat wave like there is now going on. And it was, I want to say this was in the St. Louis area, and the temperatures were in the high 90s, low 100s. And the complaint from this customer that somebody was trying to help was that he couldn't get his house to 67 degrees indoor temperature, right? So when I size a heating system or an air conditioning system, I have to size it based on these ASHRAE standards.
So there's the guidelines that are given by ACA.
Mhm.
So for residential stuff, it should be following.
ACA, Air Conditioning Contractors of America.
Correct.
Okay.
So ACA Manual J will define what those conditions are.
Right. So there's a set condition. So do you recall the design temperature for the area we're in right now?
As far as the ambient design temp,
Yeah. For cooling.
for cooling, it's usually like in the 90s, low 90s, I think.
Yeah. I thought it was in the 80s, like 85 or 86. But let's just, okay,
Well,
let's
run with some number.
forget that. Yeah, let's just pick 85 degrees for a cooling,
Right.
the design temperature. When it's 85 degrees outside, my air conditioning should be running continuously to maintain, I want to say the design temperature indoors, I think it's 76. I could be wrong, but let's just stipulate 85 outside, 75 inside, just to make it easy.
75, 50% humidity.
Right, 50% humidity. So my air conditioning system should be running when it's 85 degrees outside continuously to maintain 75 inside.
Right. It's being sized for that exact
Right.
condition.
So if I decide if I'm above 85 outside and above 75 inside, I'm not going to change the temperature in that space
Right.
for a while.
If the system was sized for 85 ambient, 75 indoor, and you're trying to maintain 67 indoor and it's 105 outdoor, the system's not sized for that.
Correct.
And it's intentional because if you did size for that freak event that's 1% of the year, your system would be oversized 99% of the time.
Right. And this was years ago, and I'm not sure if it's still accurate, but this is probably goes back 15 years, maybe even longer, where I read an article, according to ASHRAE, that in an industry magazine, that on average, we have about 7 design days a year. That means that 1 week a year, we have those design temperatures. The other 51 weeks, we're below that.
Right.
So if I oversized it, I wouldn't remove as much sensible heat.
Or latent.
I'm sorry, the opposite. I wouldn't remove as much latent heat. I wouldn't have humidity, so I would feel cold and clammy.
Right.
And in the heating, if my heating system is oversized, it's going to come on and I'm going to feel really warm, and then it's going to cycle off and I'm going to get cold.
Right.
So it's like that. It's designed that way.
It's
for
very
a reason.
intentional. Yeah. It's not just being like, hey, we're just going to size it arbitrarily for these conditions. It's saying, hey, this is the science behind how the system should operate at part load, which is the majority of your operating season.
Yeah, and this person I was talking to, I was trying to explain to them that this, first of all, it's comfort cooling, and the indoor design temperature shouldn't be at 67 or 70. I think 70 is the low point on comfort cooling. Anything below 70, I think, is high temperature refrigeration or medium temperature refrigeration, I think it is. But we should have told the person, that's it, your system is doing what it's supposed to do. It's not supposed to go to 67.
No, that's not a reasonable temperature. Right. That's just, do you want to turn your house into a walk-in cooler at that point? And that system is not designed to run, meaning the compressor. That compressor is going to take a beating running at that temperature.
Well, yeah, and think of it
lower than 67.
From a thermodynamics perspective, the ability to exchange or to achieve heat transfer diminishes as the air temperature goes down. So you have to work harder, use more energy as the indoor temperature goes down in cooling. If it's 80 degrees and 67 wet bulb, you got a ton of energy in that air that you can exchange heat with. So the lower it is, the more energy penalty, the harder it is to produce capacity at that point.
Yeah.
Yeah, this is important because it clears up a lot of misconceptions and a lot of, I get contractors all the time that say, why can I not turn that Mitsubishi remote down below 67 degrees? Like, why do you want to?
Yeah, exactly. You shouldn't be able to.
So
it's no longer comfort cooling. It's because refrigeration is segmented into it is comfort cooling. There's medium refrigeration, low temperature refrigeration. You're going to find that in grocery stores.
Yeah,
the low temperature.
Exactly. I want to live in a grocery store.
Yeah, it wouldn't be bad. Not the grocery store in my town. Somebody needs to get fired. My wife works in this grocery store, and for the last 6 months, every other week, the whole refrigeration system goes down. You can't go in there and buy anything that's refrigerated. No meats, no dairy, nothing. And I'm like, somebody needs to get fired. It's either the refrigeration guys aren't doing their job, or it's the most likely the managers in charge are too cheap to fix it right.
I'll take another Band-Aid, please.
Yeah. But, and I want to go back to this because I remember more than once, you give somebody air conditioning. They never had air conditioning before. And, you'd put it in there, and the first hot day they get, it's 85 degrees, 90 degrees outside. They come home at 3 o'clock, turn on their AC. It's been off all day. It's 85 in the house.
Yeah.
And hey, our air conditioner's been running for an hour and it's not cooling. Yeah. you have to explain. And this is part of the problem. A lot of times, we had an episode with Chris Moore, and then one of the topics we talked about was integrity. And a lot of times we don't explain to the customers how these systems work. That customer who said, I want my house to be 67 degrees, it's our job to explain to that customer that that's not possible. That's not the way. And if that customer wants it sized for that, then we need to walk away, I think, and say, no, we can't do that. That's a disservice. You're going to be uncomfortable the whole 51 weeks out of the year. You're not going to be happy. So you have to do what's right.
Well, yeah, it's all like you bring up a good point about the handoff between the contractor and the homeowner. Typically, it's system's done. Here you go. Here's your remote. Go figure it out. Instead of telling them, hey, it's better to use the set it and forget it. As far as energy efficiency, just let it coast all day. And that piece is missing a lot of times. Maybe there's one guy in the shop that knows exactly how this thing operates, how to set it up, what the best parameters are, and everybody else is just, there you go.
Yeah, people ask me that all the time. What should I set it to when I'm not home? Mine is set to a temperature, and I leave it. I'm done. I set it for air conditioning in the summertime. The only time I change it is because I'm not, believe it or not, I'm not really a fan of air conditioning. I'd rather have the windows open.
Really?
But we've had some
What are you doing here?
Yeah, we've had some heat and humidity these last few weeks. So once my window's closed, my AC comes on, and I haven't touched it. Once the cooler weather gets here in the fall, I'll open the windows. I'll do that. But once cold season starts, that's it. I'm setting it for a temperature, and it's staying there. I don't do setback.
But that's what you think, Paul. When you're not home, your kids are cranking that thing down.
Oh no, they don't. They don't know how to use it. Actually, I just got the new Power 42. So I haven't showed them how to use it. My wife figured it out, but
it's a tough one.
Yeah, the one I had before was a unitary that I could lock out. It was probably a
special code.
Yeah, special code that they couldn't use. But now I have the Comfort app now, so if they turn it up, I can check and turn it back off.
Yeah, I'm threatening them with a Nest. I'm going to lock them all out of it. Once I get home, it's like it's set for 65. I want to kill them.
Yeah, but I had a customer who years ago we put in a furnace for him. We took out like a 60% efficient furnace, if that, and we put in a 90%. And of course, it was a lot smaller than the one we took out. The one we took out would blow like 300-degree hot air, and it was probably 200,000 BTUs. We put in an 80,000 BTU furnace. And this guy's complaint was when he went to work in the dead of winter, it would be like in the 20s or teens outside. He'd turn off his heat when he went to work. And he'd come home, his house would be 50 degrees. I said it took too long to recover. I said, listen, the money you're saving by not having the system on all day, you're losing that savings.
Yeah, as soon as you kick it on.
As soon as you kick it on, trying to make it up. Just leave it alone. Go 3-4 degrees, but no more than that. If you want a setback.
Yeah.
Right. Anyway, are there any other?
I think we covered the acronyms that, again, in class I get questions all the time, and no one really wants to admit they have no idea what SEER means. They don't have no idea what COP means. They just know that a higher number means it's good. But now I think this episode clears up a lot of that. This is fantastic. I'm going to have to go back and re-listen to this just for my own knowledge. But
yeah, and again, Paul hit on it earlier, where it is a level playing field where everyone should be following the same test setup procedures, following the same guidelines of the AHRI standard. So you can kind of look at a piece of equipment and say, all right, this is 15 SEER, this is 16 SEER. I know that this is better by a third party. And this third party rating is all checked on an annual basis. So there's performance audits where the company AHRI actually picks certain combinations, pulls them into a lab, sets them up how you define them in your submission. If you fail, you have to retest or you have to rewrite.
Yeah, but we're not the only industry that does this. For automobiles, when you have the miles per gallon, all this, there's a certain way you have to test it. So it makes it all equal. And I don't want to mention the manufacturer, but there was one car manufacturer that kind of cheated a little bit. Instead of putting
Dieselgate.
Yeah, instead of putting all the tires on there, they only just put one, and they kind of got away with it, so it threw the numbers off. But
I was thinking about the other one, the rolling road dyno, where it goes, "Oh, I know what I'm doing right now."
No, we don't want to go there. I don't want to get yelled at.
We don't want to name names.
Yeah. So yeah, and I forgot, even on your business card, there's some acronyms on there. So it has your name on there. It says Matt Sooy, and I think you took them off, but he used to say lead AP, BD, and C, and CEM. So let's go through those. What do those mean? So
lead's another industry.
If you don't know what they mean, you shouldn't be putting them on your business card.
I forget. I'm lapsed on it all, so that's why I'm pausing. But it's the leadership in energy and environmental design.
All right, and AP.
So AP is accredited professional.
Yeah, and BD plus C.
Building design and construction.
And then CEM.
Certified energy manager.
Okay.
I can handle energy.
Okay, good.
Certified.
I can't handle energy. All right. So that does, there's a lot of them, and there's a whole bunch of them. I mean, even BTUs and BTUH and everything. There's, we did the CFCs, but there's CRAC. I like CRAC. Computer room air conditioner.
Oh, yeah.
And then there's PTAC.
Well, don't forget, let's go back to the BTUs, because everyone in our industry talks in BTUs or tons.
Yeah.
So 12,000 BTUs equals 1 ton. Is that the amount of energy to melt a block of ice in some certain dimension? That's the origin of it?
Yeah, the origin of it was it's how long it took to melt a ton of ice, but it wasn't it wasn't 12,000 BTUs an hour. I think they did it in a 24-hour period. Was that come out to like 288,000 BTUs or something like that? And they figured out, which is kind of crazy, because when they come up with that, it was, what was the temperature outside? Was the sun shining on this ton of, where did they have this ton of ice? Yeah, but so listen, the first person to set the standard sets the standard.
That's right.
First one in. Yeah, the first one to figure it out. So I've always explained to BTU, you take a Bic lighter and you flick it and you light it. That's a BTU.
A Bic thermal unit.
Yeah, a Bic thermal unit. And it's and I get a kick out of it. It's called a British thermal unit. And I've always wondered, was it really the British that came up with this?
I don't know.
Yeah.
It's a good question.
Yeah, we'll have to save that for another episode. And if any listeners out there, if we're missing any acronyms that you want more of an explanation on, email us, send us a text through our fan mail option, and we'll try and do an episode on some of those.
Yeah, VRF versus VRFZ.
Oh, wait, VRFZ? Oh, for zoning?
Yeah.
Oh, yeah.
Oh, other guys use that one. We're always been VRF.
Yeah. There's others, too. But there's so many. The VAV.
Yeah, variable.
The VAV box.
Variable.
There's, of course, TXV, which
thermal
probably aren't very common anymore. VFDs. The VFDs is part of our industry. And, of course, WC.
Water column?
Yeah, water column. UV, ultraviolet. There's, you mentioned SP, static pressure, which could also be set point. I mean, there's just outside air temperature, I think we mentioned.
Did you know we actually have a glossary, a Mitsubishi glossary?
We do? That has all these in there? We probably should have grabbed that before this episode.
Not the standard ones, but all the ones that we use in our day-to-day at METUS.
Yeah, we use a lot.
Yeah.
We use a lot. And then, we have our... the joint venture. I'm sorry. We have our joint
JV.
Yeah, we have our joint venture with Train, and it was the JV. And I thought we had a lot of acronyms, but they bring a bunch more over. Like they got more acronyms than the military. Mm-hmm. And Wilma, we use Wilma. That was an acronym. The thing
Wilma.
we use for webinars.
Yeah.
So, I got one. You know this one? HPS.
HPS.
You probably won't.
High pressure switch.
Oh yeah, it could be high
cool.
pressure switch or high pressure steam. It could be.
Which one were you thinking of?
I was thinking of high pressure steam.
Okay.
FLA.
Full load amps.
FPM.
Feet per minute.
GPM.
Gallons per minute.
Okay, you're good.
Keep going.
Here one. ECO.
ECO.
I know this one.
What's the first word?
Energy.
Energy Conservation Organization?
Oh, close. Energy Conservation Opportunity.
Opportunity.
Yes. And then there's DP.
Differential pressure?
Yeah. Or dew point. Very good.
That's true.
And of course, now you got DIDO.
Yeah. Digital input, digital output.
Yeah. Oh, here's one for you. Oh, no, that's not the one. I already gave you that one here. IPMVP.
Integrated.
No, they're never going to get this one. It's International Performance Measurement and Verification Protocol.
That's just tab. Testing and balancing.
It's what that is? Probably. We don't even have tab on here. Testing and balancing. We should. If for no other reason. For
Scott Tallman
Rowland.
could go into
All right. I think we're boring enough people now, but I'm glad we got to the bottom of the SEER and EER and COP and.
Oh, don't forget the whole SEER versus SEER 2. It's very important.
Oh yeah, what is SEER 2? I don't even know what that is, to be honest with you.
So the AHRI decided to come out with the M1 appendix for 210, 240, and that's shifted everything from EER, SEER, HSPF to EER 2, SEER 2, HSPF 2. So it was supposed to be a more accurate reflection of performance. The main difference was how they treated ducted systems, forcing them to test at a half an inch of static. So the biggest hit was to our ducted systems as far as the efficiencies going down from a SEER to a SEER 2 on a ducted. The non-ducteds pretty much stay the same between their SEER and their SEER 2.
Interesting. So again, when you're testing something, they want to test apples to apples. So they have to set something as fixed. You know, it's either the compressor frequency. In this case, for the ductwork, they set it at just say half inch?
Half inch, yeah, for conventional.
Half inch of static pressure.
Right. So we had to go and re-rate every single one of our combinations that were still on sale after January 1st, 2023, I think it was. And then we had to rate them all to the new standard.
See, in my mind, the problem with these standards is they're okay with old equipment. Single speed compressor, single speed fan. Right? Everything's always running at the same speed. But now, we have ECM motors, electrically commutated motors, and variable speed motors. That kind of changes things with static pressure, because now the static pressure is a variable. And now we got the inverter compressors. It's not just a single stage compressor; it's a variable speed compressor. So there's a variable there now. So you got to fix these things, and it does allow you to compare apples to apples, but it doesn't give you, in my mind, it doesn't give you a true reading.
No, it's just a single snapshot in time. That's again level playing field.
Yeah, I wonder if they do that with vehicles when they give you the miles per gallon. Is it locked in at a specific? It is a specific speed,
a specific test.
And then city and highway. I always wondered which city are they in, because if you're in Boston, it's a lot different than if you're in Manhattan. The northern part of Manhattan. Anyway.
Yeah, so you can play. It's a game at the end of the day, as far as getting your numbers to be the best they can within the bounds of the standard. So you look at a car's MPG rating, and then you say, "Hey, I don't get that same MPG rating because you don't drive exactly like the standard."
Yeah.
So,
if you did, you wouldn't get anywhere.
You'd get rear-ended.
Yeah.
When merging into traffic.
Yeah. And if you're not moving when that light turns green, you're gonna get yelled at.
Quarter second.
All right, Matt. Thanks for joining us.
Thanks, Paul.
And
thanks,
hopefully we clear things up for folks. If not, we'll find out. We'll get some
definitely
emails.
did.
All right. So you ready to get some sushi?
Yeah, exactly. Oh, we didn't discuss my favorite sushi not in the U.S. So,
where was it?
Uni. So sea urchin tastes like a raw egg meets the ocean floor.
Yes.
So it's very love-hate kind of relationship with it, where it's just so unique of a flavor.
And you had that in Japan?
I've had it in the U.S. and it's not nearly as good.
No, I've had it in Japan, and it's kind of strange. It's
it's gooey and very briny.
You won't see. I don't mind. I mean, do you eat raw clams?
I can't. I'm allergic to clams.
Oh, you are?
Yeah.
Wow, that's awful.
I eat oysters, though.
Okay.
So I'm split.
But that's interesting. You're allergic to clams, but not oysters.
Yeah, I got a weird shellfish.
Yeah, but if you can eat a raw oyster or raw, like little cherry stone clam, the sea urchin thing is not. As far as the texture, it's not that different, but it's a very unique flavor.
Yeah, it's like the briniest oyster you've ever had.
Yeah. Yeah, it's, and like you said, now that you mention it, it's like having a raw egg that tastes like an oyster. It's really, really salty.
Exactly.
Yeah, but in Japan, there was other things. You get
a lot of toro over there too, which is the fatty tuna.
Yeah, no, I didn't have that. I know there was one thing, I probably mentioned this before on the show. There's one thing called natto.
Oh yeah, those fermented soybeans.
Yeah, fermented soybeans. And I asked one of the guys, I go, "What is natto?" He goes, "Do not eat. Come from very bad place."
Very good for you, though.
Yeah, and then Bubba was there with me, and they have these like these pickled plums. They just the plums, and they just pickle them for whatever, and they're just real, not quite turned into a prune, but you eat these things, and it's just, I'm sorry, I didn't like them at all. I don't like anything pickled, but they were very tart. Like you reminds me of the Three Stooges episode when they're all playing cards and they drink this alum. And no one could talk. Their mouths are all puckered up. Anyway, I digress.
So you wouldn't even need a pickle?
I like the I don't know what they call the dill pickles. They're not quite as vinegary.
Oh,
like the thing you get like
bread and butters.
Like in a Jewish deli.
Oh, the half sours.
Yes, those are okay. But other than that, no. I'm the only one. I don't like vinegary things.
Oh, it's good for your health.
That's why I don't like Tabasco. Tabasco's too vinegary for me. I prefer Frank's Red Hot.
Yeah, Frank's is a good choice.
Yeah, but listen, we could do a whole episode
on hot sauces
and slap your mama hot and those other ones.
My go-to is the Trader Joe's jalapeno sauce.
Yeah, that's
green sauce.
Yeah, that's a good one. I make that homemade. I don't use a jalapeno. I make it homemade. I don't know what the peppers are, but I get them from a local farmer. He calls them Surefire Hot, which I can't find online, but
it's not a real breed.
No, I get a couple of bushels of these, and I grind them up, put some salt in there, and then can them. And I use that to cook all year long. I gave Steve a jar about 3 years ago. He still has it.
Yeah, I had to throw it out, but when I did use that, I put a very small amount into the chili I was cooking, and it was unbearable. You couldn't eat the stuff. So that was some very hot crushed red pepper.
I make a soup. I use half a jar.
Well, that's it.
I'm not kidding. I use
firehouse chili.
Yeah, no, I love it. I make chili. My chili, I probably use a whole jar. I'm talking about a pint jar. Yes, a little pint jar. I'll probably use a whole pint jar.
A little goes a long way in soups because it just goes everywhere.
Yeah, and it's so good. I love soups with a little heat in them. I go to a sushi place. I'm going to get tom yum soup.
Oh, yeah,
I love that stuff.
Yeah, I made a Zorian octopus yesterday, which people have been asking me to make. I had 6 pounds of it at home, and it's basically it's a stew, and crushed red pepper goes into it. I had to package it all up yesterday and ship out little Tupperwares to my brother and my other brother and friends of mine and to try it. And yeah, it's fantastic.
Octopus.
And it's cooked.
Oh, it's delicious.
It's cooked. So that's important.
Yeah, I do that. I like it. I prefer it in the oven. That's good.
Yeah.
All right. We'll talk to you later.
See you on the next one.
Bye.